Today I will talk specifically about a hot topic, which is 5G, but I will talk about it from the context of the changes in high-speed solid-state memory that enable the 5G experience to be a better experience across primarily mobile devices, but I will also touch on devices that are slightly less mobile. In this presentation, you will see a number of things that are certainly forward-looking. You're all accustomed to projections, certainly in numbers of deployments, and with 5G, anytime you talk about that, there is certainly a time scale there that is still subject to change and different in different parts of the world. Where I will talk today, certainly in mobile, and you're very accustomed to the middle picture, is 5G in the context of a mobile phone. I will be broader today than just the mobile phone context, because mobile devices that are changing actually very rapidly are the cars around us. I will touch on what does this mean to self-driving vehicles, but also more mundane, what is happening today with the cars that people buy every day around the world. And then on the far right side of the slides, you will see that this is not just limited to the devices you hold, the car you drive. It is actually also a picture of the world around you. Whether it is IoT in its broadest sense, whether it's smart factories, whether it's smart cities. It would be amiss to not talk about the devices that go into the devices that I'm be talking about, right? So on the mobile side, I think you will recognize a lot of the devices already. The very recognizable USB stick, right? Everybody has grown up with that one. A way to get data on and off your mobile device at ever increasing speed, but primarily still I have data here, I need to get it on a different device. The devices you see below that on this picture are devices that are embedded devices that go in a number of your smartphone, a large number of your smartphones, where it provides the primary storage, the flash storage in your devices. And as you know, those capacity points have been going up, and those capacity points have been going up for very good reasons. What you do with a phone, and certainly what your kids do with a phone, has changed. It is changing. It is not just about, can I download a movie? How long does it take when I have to head off to the airport? Right? It's also about kids creating, and certainly some of you creating, experiences on your phone. I don't have to talk probably about services like TikTok, but I can certainly tell you that my kids spend time on not just the consumption side, but the creation side and the ability to share that data. Now, those devices are generally built into either the mobile phone or to the PC. You can imagine with automotive that a car manufacturer today will look at those mobile devices and will say, okay, but what is my car going to look like? Right? I have different qualification cycles, I have different requirements on quality, but I want to have an experience that is actually, by and large, a mobile experience. I want the same resolution screens, right? I want higher resolution screens, I want an updated experience, I want something that can be customized to my user. So we see more and more of our customers who are either OEMs or tier ones asking for that storage capacity, those storage solutions, at automotive quality grades, at automotive specific optimizations. So you will see in the middle a large number of devices that are optimized specifically for automotive. They are certainly automotive grade. In many cases, they also offer data throughput or reliability in line with automotive requirements. Not just embedded. On the bottom, you see 3 devices that are SSD devices. So more and more in automotive, you will see storage go up from relatively small 8, 16 gigabytes points to aggregated storage. And certainly in self-driving cars to storage that goes into the terabyte. And then on the right, you see those same solutions in a broad sector of industrial applications and edge applications. Some more consumer, some much more in requirements on the automotive side. And I think we talked about it before, 30 plus billion devices. We can certainly debate, is that 30 billion, is it 60 billion, is it 20 billion? It is a large number of devices that are going to be connected, that are already being connected today. Those devices are no longer limited by the number of people. How many phones can you buy? Can you hold 2 phones, maybe 3 phones? Very challenging. This is about the number of devices that talk to each other, that interact with each other, that work with you. Generally called IoT, but in general, the number is higher than the number of people in the world. And some interesting statistics there, right? It is about cars, self-driving cars. Here it says conservatively 4 terabyte a day. 4 terabyte a day of data that is in many cases transmitted, but is certainly stored on the vehicle itself. Initially for development purposes, but you can imagine long-term also people want to know how decisions are made in a self-driving vehicle. It is not always a clear algorithm, right, of the person shows up here, another person shows up here, what does the car do? It is machine learning, so you have to have a lot of data points. You have to understand exactly what decisions were made. That is driving 4 terabyte plus per day. At CES, less than a month ago, the company said it's actually 4 terabyte an hour that is being generated on those vehicles.
All of this, does it mean that in 5 years from now, we will all have 5G and we will have the same identical problems that we have today? I mean, so we now are with 5G, 4G, and a couple of years ago, 5 years ago, only one device per car, I mean the phone.
Yeah.
Now we have, you know, the watch, the phone, and maybe the car is beginning to send some data somewhere. And in 4 years from now, we will have more devices. Everybody will be connected. So the bandwidth is 10 times what we have today, even if it's 100 times. Doesn't change much. I mean, we will have the same problems.
I think
just a different scale. But
I think the philosophical question is there ever enough storage? Is there ever enough memory? Right, going back to the PC days.
I mean,
or will it ever be? Will it always be used? I think our position is that data generally will be generated. I think these pictures show it, right? We show video recording at 8K of terabytes per camera. So I do believe that the data will be generated. On the automotive side, there's a lot of discussions at an OEM level, at a tier 1 level, of what is kept on the vehicle and what has to be transmitted, right? Cars still have to drive even if the 5G connection is not there, right? So a lot of architectural decisions, data will be stored on the device, it will be kept, whether it's a mobile device or whether it's a car. What is being transmitted is important because I think you are right that if all data from the car, the self-driving vehicle is transmitted, we will very quickly be limited by 5G connectivity. I think also the question of privacy, right? There is some data where people are going to be tremendously nervous if that data is live transmitted. Where does it go? To your insurance company, to law enforcement. So we had an event here on campus on November 14, Data-Driven Future, where we brought together certainly people from inside Western Digital, but also people from the regulatory perspective, people from self-driving car companies. And we had a full evening discussing how is policy going to be set? What role should the storage industry play in that? What role should the car industry be playing? So I agree with you that I think 5G, the data will be there to saturate 5G links. I think specifically automotive, there's a very measured way to talk about what data needs to be transmitted.
All right.
All the data will be stored. Does it answer your question?
Yeah, no. From your point of view as Western Digital, I agree. But from the consumer point of view, it's just that we will have more of everything, but the same identical problems. So 5G is not the panacea for everything. I mean,
and there has to be room for 6G also.
In that they need to sell something new. But
correct. And I will show you certainly what headroom we have there. I agree with you that evolution will continue. So we talked about the cars, we talked about the video recording. Here are some other interesting numbers that show exabytes of data being transported. Now, connectivity, as was mentioned, it enables us to send a lot more data. As a result, the applications, whether that's going to be on your phone or on your car, are going to become more demanding. It is not just simply a consumption case anymore. And applications will grow to take advantage of both the storage capability as well as the transmission capability. Those have to be balanced, and it will lead to architectural changes.
A lot of cat videos.
And we see today when we talk to our customer base, certainly in automotive, that they are talking about deep architectural changes on how memory works in a car. What is aggregated, what is separate. You can imagine that it's not a simple discussion of combine everything in one storage system. Where does the black box go? Where does the computer go that takes all the LiDAR and camera images? Where does your entertainment system go? How does it all work together? How does it work over the medium, whether it's hardwired with Ethernet or 5G? And the opportunity or the challenge, however you want to look at it, is here, right? If you look at this slide here, it shows 4G as the dotted line. And in the past, whether you were eMMC storage, 4.5, 5.1, or UFS, the highest speed storage mechanism, you were limited by that link. So for devices that relied only on a 4G link, all of these storage methodologies were all fair game. It would saturate the link by itself. it was not a bottleneck. Now, for us, certainly, life is changing. If you look at the 5G dotted line, it sits much higher on that graph. And you can see quickly that if this is about a single device, eMMC is no longer a device that is even remotely going to saturate. You look at UFS 2.1, which is relatively new, it comes close. UFS 3.0, right? You see it rolling out now on the mobile device side, on your handset side. Yes, it can actually saturate from a read perspective. It can saturate that link, right? You can have data being read at a speed where the controller is not the limiting factor. And certainly our goal at Western Digital is to make sure that our solutions are not the limiting factor in the user experience. But there's a detail there. And since we are here in the Bay Area, and since it's probably a good time to talk about stadiums, football stadiums, 49ers, here's a picture of certainly the traffic into that stadium, right? At 4G, yeah, you can get traffic in, and traffic may be there before the game starts or not. Right? But by and large, you have 2 lanes of traffic going into a large building. 100 megabit. UFS 2.1, you're getting there, right? I showed a picture where, by and large, you can get all the traffic to your stadium, but you're not quite done yet. And I'll talk about why you're not done yet. You would be done if the only thing you cared about really is how quickly can you read your data, a single set of use cases. And historically, probably a pretty good description of what most people did with a mobile device. But the question now is whether that's on your mobile device creating video data, or whether it's in the car creating a tremendous amount of data from all the sensors around you, is what happens with write. Right? So with UFS 3.0, certainly the write speed has gone up, but it has not gone up to be completely maxing out that link. You're still limited by a UFS 3.0 controller to write the data to the devices. No longer just a small use case, whether it's the mobile phone or whether it is actually the car, and vastly increasing use case. So better, not the end solution. What we certainly at Western Digital have spent a lot of time on is on those actual use cases, right? How can we get data on those devices as quickly as possible so that you have those lanes straight going into the stadium? So what we have enabled is what we call SmartSLC. SLC, for those of you who obviously have been in the storage industry for a long time, the very first technology to write single bits into a solid state memory, right? Today people talk about MLC, TLC, QLC, PLC, whatever goes about it, more and more bits. But it slows down the write performance. So we have found, our engineers have found very creative ways to be transparent to the end user and to have the fast write performance of a SLC.
They have a hybrid SSD with SLC and MLC and TLC in it?
And it is dynamic, so you can actually over time partition that differently. So it is a very creative way of actually having the long burst throughput of an SLC in a device that has the advantages from an overall performance cost perspective of an MLC TLC. And as you can imagine, certainly in consumer devices, as more writing is happening, this is getting a lot of traction, but also in automotive, where people want to have that SLC performance to guarantee that the data will make it quickly enough into the device. So this is the solution today where we talk about at a UFS 3.1, it enables full read, full write to maximize that 5G link. So 5G, the endpoints are there, right? I think I showed it before. There is no doubt that the endpoints are there to saturate, whether it's on a single device, to the earlier question of, are we going to have the same problem? But more likely in multiple devices, saturating that link. It is talking about certainly the instant performance, right? The attention span of people has gone down. My teenagers certainly have a very, very small attention span. It is about how quickly can I get my data, whether that's in AR, VR, whether it's in gaming, whether that is in an industrial sense where the latency becomes incredibly important. So, interesting stat, I'm sure most of you have seen it, right? But just to refresh ourselves on that one, when you're still heading to that airport, 5G by itself still offers that advantage of, and it's actually good to think about it. Instead of on 3G, 26 hours to download your movie, 3.6 seconds, right? So, I don't know about you, but I've been on multiple occasions going to the airport where I need to get that movie on my device. 5G does solve that issue. My presentation was here to show that that issue is important. I think people will value the 3.6 seconds, but 5G will enable a lot more, and a lot more than just the one use case that we had in the past. These are the use cases where devices will dictate that data has to be written and read like the automotive self-driving car use case.
Can I just ask a
Yeah.
question about that slide though? Because I always see those sort of numbers being shown and think it's just fantasy compared to what we actually have.
Yeah.
You know, so I've never had 100 megabits a second download on 4G.
No,
There are bits in London where I can't even get a proper 4G signal.
fair enough, right?
And I certainly think that that doesn't belie the infrastructure that has to sit behind that to make that work, that we would need to spend a fortune on. So
And I
although
agree.
the technology would deliver that, the reality is that it's going to take decades to get to that.
I agree with you that these are the optimum performance single connectivity use cases.
It's like your MPG figures
Right.
cars produce.
Yeah.
Have you ever hit those numbers?
I don't look at mine. Mine's horrendous. So it's a number I never look at in the first place. But I know what you mean.
Yeah, it's the same sort of thing.
So I think from an order of magnitude it is correct. I think the 5G build up.
I'm not disagreeing with that side of it. I'm just saying that in general, you know, I think that we're overly optimistic about thinking that that's what we're going to walk around and have every single step of the way.
I agree with you there, and I think the time scale, hence the forward-looking statements. I think this statement was made before that 5G in China is rolling out. The density of the 5G cells also has to be denser, right? So the infrastructure side of that is a whole different discussion.
Yeah.
So some interesting data point, right? People ask us all the time, what is the capacity on a smartphone? Is that going up? Does it keep going up? This is a graph of certainly external research as well as our own data on average data points of capacity. It is going up, right? The question of is 5G going to immediately drive a much higher capacity in the smartphone? I think our customers generally don't see it quite that way. They say the higher capacity points at 256 and above will probably be there also in 5G initially. But they also look at the data creation side and they say people are creating so much more data that certainly 256 and 512 will fill up in those use cases relatively quickly. So it's not just about technically can we enable more storage. Certainly my engineering teams and my R&D teams will say that can be done anytime. It is finding that commercially viable point where you have enough storage on your devices to create those use cases at 256, 512, 1 terabyte. And as certainly we will hear later, what happens in the data center, what happens in the cloud, so that not everything stays on your device.
Have you analyzed the power consumption demand for these 5G situations? Because you're using so much more storage, right?
Yeah, and I think power is becoming a more and more front and center topic. Mobile devices, obviously, battery life has always been an important differentiator. How quickly you write your data to flash has become, over the last, I would say, 6 months, a very important topic, because the write use cases are becoming more and more prevalent, and writing bits takes quite a bit of energy. So two schools of thought. One is how can you lower the energy you use per bit that you need to write. The other one is how quickly can you write it. If you can write at a slightly higher power quicker, the area under the curve, the power still becomes lower. So our ability in many cases to write quickly actually also has power saving implications, as counterintuitive as that may sound. But certainly given the use cases, that has become much more front and center, I would say, even over the last 6 months. So, and then autonomous vehicles, we talked about it, right? The graph is going up, and it's going up steeply. As I said, we have customers talking to us about 4 terabytes per day being generated. We have customers who are installing today what look like data center racks into cars. Admittedly, those are the early self-driving level 4 and level 5 vehicles. But our belief is that certainly per vehicle in mass-produced vehicles, it will exceed the terabyte. A combination of UFS embedded as well as automotive-grade SSDs. And then a number of reasons why that 5G enables the link. So one storyline could be then all the data will only be in a data center. It will only be in the cloud. I think from a Western Digital perspective, I think we benefit on both sides. Data will be in the cloud, data will be in the data center, and in many cases that will be enabled by us. But also there's a reason why data will reside in larger and larger quantities on the device. One is if there's no connectivity, I can guarantee you that the desire for a self-driving car is to keep driving. So extreme example, but by and large, why the cloud users and the data center users take up, I think it's keeping pace with the desire to have data on the device itself. I don't see that, we don't see that go away anytime soon. In fact, with the rollout of autonomous vehicles, initially that will even lean more towards data on the device from a latency perspective. And latency is important, right? How quickly can you get to your data? If your teenager is impatient, maybe that is 20 seconds latency. Probably not, it's probably seconds, milliseconds. For mission critical systems on the car, you can imagine LiDAR camera units, that has to still be local. And then overall is the cost, not just the cost of building the system, there's the cost actually of the data being transmitted, right? Depending on where you are in the world, cost is certainly there to transmit terabytes of data over a pipe. Today, if you look at your plan at home for your internet, it probably caps at a terabyte at this point per month. I just showed that 8K cameras can do that actually in a day, right? So you can start thinking about your doorbell camera potentially actually taking out your allotment for the month in a day, right? So cost not just of the implementation, but cost also of the data transmission. And certainly it's not on this slide, but privacy is becoming a bigger and bigger deal, right? Data being processed closer to the actual point where it's generated and the user having the ability to choose what information is being transmitted. Raw data being transmitted is a hotly contested topic in the US, in Europe, and worldwide. And certainly you can see legislation in many places, including California and Europe, that will regulate and are regulating the amount of raw data that can be transmitted.
Is it the raw data that can be transmitted that is being looking at, or the actual creation and transmission of the data itself?
I think it's both, depending on which geography you're in. I think there is the legislation which tends to be behind where people's concerns are, right? And I think in many cases it is just not knowing what happens with the data, and it's vast amounts of data, right? So a lot of customers will look at, can I just create and be clear about what information is being transmitted, right? Is it just a facial recognition where it says it's this person, or is it actually a 1080p stream from somebody's living room, right? And there are differences in that, right? So I would say it varies widely. We certainly work with the industry on our view and how we can enable on our storage, which also has computational capability, to look at machine learning to enable data to be segregated. And then in general, right, we should not avoid that topic. There is value in data, right? There is actually, depending on how you look at it, tremendous value in data. And our customers certainly look at that and how can they capture part of that value. If you are a car OEM, can you get value out of the data generated by your vehicle? A lot of car OEMs look at themselves also as connected vehicles with shopping capabilities, especially in an autonomous car. So the same question of what can they monetize? Your insurance company certainly has a view on what the data is worth, and you can see that in ads today, right? You will get a discount as long as you provide the data, right? So vehicles in the future are no longer just getting you to A to B. You can make the case that if the car is completely autonomous, it is a living room, right? You are consuming data, you are generating data, not any different from being in your living room. We can argue we are fairly far away from that today, but companies are gearing up, whether it's on the car manufacturing side, on the infrastructure side, on the insurance side, for that scenario, right? So certainly for us, storage of this magnitude adds a certain amount of cost to the system. Some is needed for safety, and some, frankly, enables the generation of the data that will actually be monetized. So from a Western Digital perspective, today, the point I want you to walk away with is that high-speed solid-state storage is changing. It is changing because it has to enable the 5G introduction, which will happen, to be maximized, right? What can you do with 5G should not be limited by our devices. I've made plausible, I think, that with the devices today that we have shown, which are commercially available, that we are able to, from a storage perspective, saturate that link. The data that's being generated is data that is stored on the device, it's manipulated on the device. Machine learning was discussed earlier. It is also data that is transmitted, and as you will hear also on our data center side, that data will be on both sides of that link. 5G for us is something that fundamentally has changed our thinking on the devices we need to make. It has also changed the thinking for us as a company with our ecosystem on the important questions we're asked on what happens with privacy, what happens with machine learning. Right, so it's a step that is above just storing the bits. It enables now the discussion of what does the architecture look like and what can run on those architectures.
I have a question around the sort of the cost aspect. If we're talking the rollout of 5G and you're talking greater density on a personal device, and you think of what the cost is on a top-end smartphone at the moment, there's going to become a limitation to the people that can afford that technology to begin with.
Yeah.
Is that not going to slow down the adoption side of things for the time being?
I think what you will see realistically, as you see today, is that there are solutions, there are phones available that go from a fairly basic storage level, which is going up to a terabyte and above storage level. The use cases will be different. I think they will be positioned differently, right? As you see in gaming, there are enthusiasts that are willing to pay more. There are people who want the basic functionality where the capacity will still go up and you will not get that level of performance. That stratification will continue to happen. I think certainly there are a lot of things that you are aware of and that you will hear more about what Western Digital is doing to drive the next generation memory technologies to also make sure that those stay cost effective at higher capacity points, right? So there is certainly a stratification on the use cases. There are enthusiasts and there are basic users, and certainly part of our roadmap that you will hear more about will talk on the memory technology side about us being able to offer those solutions where the capacity can continue to go up and still the end product be commercially viable.